Good morning student friends. In this video we will see explosive forming process, which is the second process from unit 5, that is advanced forming processes. Now first of all we will see its introduction. Whatever punch we are using in case of conventional forming process is replaced by an explosive charge. Means in a controlled atmosphere we have to carry out the explosion. Explosion means sport, and the waves created by that explosion we have to use for deformation of the metal. Whatever explosive used in this process, they are the high energy chemicals like a TNT or RDX or dynamite we can use as an explosive charge. Again we can use also gaseous mixture, various gases, that is acetylene gas, butane, methane, all these gases we can mix in a proper proportion, and that mixture of the gas also we can use as explosive. Again various types of propellants are available with the petrochemical industries, that pet, that petrochemicals also we can use as a gaseous, propellants also we can use as a explosive charge in case of explosive forming process. Now there are two types of explosive forming process, that is unconfined type or stand-off technique, and second is confined type or contact technique. One by one we will see this. First is unconfined type or stand-off technique. The work is firmly supported on the die and the die cavity is evacuated. In this figure you can see this is the unconfined type or stand-off technique type of the explosive forming. This black color is the workpiece which is hold on this die, and the cavity below that workpiece is connected to the vacuum line, so that vacuum is created inside this. So at this place we are creating the explosive. At this place we are creating the explosive, and this is done in the controlled atmosphere. So after explosion waves are created in this water. You can see the structure of this machine or the structure of this process. One container is there, inside that container water is filled, and at the bottom dye is placed. To that dye cavity is there, and black color is the workpiece which is firmly supported by using this hold down rig. This is the hold down rig used to support the workpiece to the die, and this is the explosive. To that explosive we have to supply the external energy. After supplying the external energy, explosion will take place, and after explosion waves are created inside that water, and under higher energy that waves are striking on the surface of this workpiece, so that this workpiece will get this dome shape or semicircular shape of the die cavity. The work is firmly supported on the die and the die cavity is evacuated. Evacuation of the die cavity is very important, so that adiabatic heating of that workpiece will not take place. Adiabatic heating, after explosion heat is produced, and that heat should not go inside the water. At the same time it should not go to the workpiece or the dies. That's why evacuation is required, or vacuum inside the working chamber is required. A definite quantity of explosive is placed suitably in water medium at a definite stand-off distance from the workpiece. Stand-off distance means distance between explosive and the piece of work, that is called as a stand-off distance. Now whatever distance you are seeing in this figure, the distance between explosive and the surface of workpiece, that distance is called as a stand-off distance, and the stand-off distance should be optimum. Optimum means as per required. If stand-off distance is more, then proper or 100% deformation of the workpiece will not take place, and if stand-off distance is very less, then more deformation of the workpiece takes place, and it may lead cracking of the workpiece, or it may damage the dies also. That's why stand-off distance is very important part to maintain in a case of this unconfined type explosive forming process. Definite quantity of explosive is required in this process. Now means whatever deformation I have to achieve, I must know how much deformation is required. Again type of metal I should know, means ductility or the material is comparatively brittle. All these things I should know, and according to that I have to select the quantity of explosive. On detonation of the explosive charge, pressure pulse of very high intensity is produced. I told you right now, after explosive, pressure pulse or the pressure waves or the shock waves are created inside the water, and under that shock waves water is striking under higher velocity on that workpiece, and the workpiece is going to deform. and it will get the shape of the die cavity. Now when the pressure pulse strikes against the work plate or the sheet, the metal is deformed into the die cavity with high velocity around 120 meter per second. Under that velocity, workpiece is going to deform. The vacuum is necessary in the die to prevent adiabatic heating. I told you, after explosion heat is created, and that heat must not go inside the workpiece or the die. Again, it must not evaporate the water also. That's why we have to maintain the vacuum inside the working chamber, which may lead to oxidation or melting. Oxidation or melting of the workpiece may take place, so we have to avoid it. Role of water acts as an energy transfer medium. Chemical energy produced after explosion is transferred to the workpiece by water medium. It ensures uniform transmission of energy, smooth application of energy on the workpiece without direct contact. Direct contact between the source of energy and the workpiece is not taking place. That is the role of water. This is unconfined type or standout distance. Now we will see the process variables in this unconfined type. Type and amount of explosive. Wide range of explosive is available. We have to select a proper explosive with its quantity, that is type and amount of explosive. Standoff distance, I told you the distance between the workpiece and the explosive is called as a standoff distance, and it should be optimum. Optimum means as per requirement. Optimum standoff distance must be maintained to avoid oxidation or melting of the workpiece, or cracking of the die is also takes place. The medium used to transmit the energy, water is mostly used as a energy transfer medium in case of this unconfined type. Work material properties, it should be ductile, but it should not be so much ductile as a conventional forming. Vacuum in the die is necessary to avoid the adiabatic heating. These are the process variables of unconfined type or standoff type of explosive forming. Next is confined type, or advantages and limitations we will see related to this process. Shock wave is efficiently transmitted through water, and energy is transmitted effectively on the work. Shock waves are created by the explosive forming, and they are effectively transmitted through the water medium on the workpiece. Noise is less probability of damage of the workpiece, as we are maintaining a standard standoff distance or optimum standoff distance we are maintaining. Large and thick parts can be easily worked, economical when compared to a hydraulic press. If we will compare hydraulic press with this explosive forming, then it is an economical process. Optimum SOD, that is standoff distance, is essential for proper forming operation. Vacuum is essential, and hence it adds to the cost. Maintaining of the vacuum is a costlier task. Dies must be larger and thicker to withstand the shocks. Not suitable for the small or the thin workpiece, which is difficult to remove from the dies. Explosive must be carefully handled according to regulations of the we know that dynamite or the RDX or TNT, these are banned by the government. So while handling those explosive, we have to take a permission from the government. Also we have to handle it properly. This is unconfined type, and related to that we will see the application. Shipbuilding, radar dish or elliptical domes in the space applications are produced by using this unconfined type or standoff technique type explosive forming process. Now second is confined system or contact type. Here direct contact of the explosive with the workpiece will take place. That's why it is called as a contact type. Now pay attention here, this is the cartridge. At the center cartridge is placed, and this cartridge is nothing but a explosive. This black color is the workpiece which I have to deform, and this is the cavity. Means I have to give this shape to the workpiece. Means initially workpiece is straight, and I have to make it slightly bulky at the center, or I have to deform it at the center. That is my purpose. This black color is workpiece. Workpiece is surrounded by the die cavity. Now at the center cartridge is placed. Cartridge is nothing but a explosive. The pressure pulse or the shock wave produced is in direct contact with the workpiece. That's why this process is called as a contact technique or confined system. And hence the energy is directly applied on the work without any water medium. In the previous case, we are using water medium to transmit the shock waves created due to explosion on the piece of work. But here, direct contact of explosive with the workpiece is taking place. That's why it is called as a contact technique. The tube collapses into the die cavity and it is formed. Now, initially, this is the workpiece. You can see here at the cartridge location, explosion is created. After explosion, shock waves are produced in the controlled atmosphere, and while propagating that shock waves in the downward direction, they will strike on the surface of workpiece. And where the cavity is maintained, the deformation, 100% deformation is achieved to that tube inside the die cavity. That is the working principle. Advantages: entire shock wave front is utilized as there is no loss in the water medium. In the previous case, as if we are using a water medium to transmit the shock waves, that's why loss of waves is taking place. But here no loss of the shock waves, more efficient as compared to unconfined type, more hazard of die failure. Important part, if cartridge. Now here the name of explosive charge is given as a cartridge. If the selection of the cartridge is wrong, type or the amount of explosive is wrong inside this cartridge, then chances of melting the workpiece or melting of the die is more. More hazard of die failure. Vacuum is required in the die to avoid the adiabatic heating. Air present in the workpiece is compressed, leading to heating. Now you can see in this tube air is present. Now as and when this explosive burns at this front portion, it will produce the shock waves, and air inside that tube is going to heat due to explosion, at the same time due to compression. That's why it is affecting on the workpiece. Not suitable for the large or thick plates. It is not suitable. Application: bulging and flaring of the tubes. We can increase the diameter of the tube locally, or you can change its cross section, that is the flaring operation of the tubes. These are the application of this confined system or contact type. Now at this point we will stop. In the next lecture we will see other process.